Okay, so we're going to look at two theorems here related to limits and continuity, the Squeeze Theorem and the intermediate value theorem. So first, the Squeeze Theorem. And you can see the statement of the Squeeze Theorem here. It says that if f of x is less than or equal to g of x, which is less than or equal to h of x, when x is near a, except possibly at a, and the limit as x approaches a of f of x equals the limit as x approaches a of h of x, which equals L, then the limit as x approaches a of g of x equals L also. So when you read it like that, especially if you're new to theorems and things, it looks a little bit confusing. But if you think about it graphically, if you look at this figure to the left here, it'll make a little bit more sense. So the first thing is this first statement here. This is like the setup, the scenario. Right? So we have f of x less than or equal to g of x less than or equal to h of x. So in other words, f of x is the low function, which is down here. There's your f. G of x is your middle function, which is right here. And then h of x is your high function, right? Your greatest function, which is up there. So if you have this scenario, right, where you always have g of x squeezed or sandwiched between f and h, and if f and h have the same limit, like in this case, as x approaches a, both f and h are approaching L, then that means that g also has to approach L, because it's always between f and h. So if it's always between them, and f and h have the same limit, then g also has to have that limit. Alright? So graphically, I think it kind of is fairly obvious to see what's going on there, right? You have g in between f and h. F and h have the same limit, so g has to have the same limit also. All right. Now it's a little bit more complicated when they give you no graph and just, a problem that'll say something like, all right, well, find the limit as x approaches infinity of 2 minus the cosine of x over x plus 3. Alright? Because now you're actually asked to find a specific limit, and there's no graphs involved or anything like that. So the first thing I would note here with this is that it involves a cosine. And one thing you know about cosine is that cosine of x, regardless of the value of x, is always going to be between -1 and +1. Alright? So the negative cosine of x, so in other words, I multiply this whole inequality by -1, which would turn this into 1, would turn this into -1, and would turn this into the negative cosine of x. But you remember what happens if you multiply an inequality by a negative sign, it reverses the inequality signs. So this less than or equal to becomes greater than or equal to, and this also becomes greater than or equal to. So I have this inequality, which more traditionally would be written in reverse order. So it would normally be written as -1 is less than or equal to the negative cosine of x, which is less than or equal to +1. Right? That's normally how you'd see it written. Alright? And now, what is the numerator of our original function? 2 minus cosine of x. So what can I do with this inequality now? I can add 2 to it. So if I add 2 to each of these pieces, -1 plus 2 will give me 1. This plus 2 gives me 2 minus the cosine of x. And then 1 plus 2 will give me 3. Alright? So I have a new inequality now. I know that 2 minus the cosine of x is always sandwiched between 1 and 3. Alright? So now this is where it gets a little bit harder to understand, I think. Right? So you see, I have 2 minus cosine of x, which is the numerator of my function that I'm trying to find the limit of. Now, that's not the function, though. The function is 2 minus the cosine of x divided by x plus 3. Alright? But, since the limit here is as x approaches infinity, we can assume that x plus 3 is going to be positive, right? Because when x gets really big, then x plus 3 is even bigger, right? It's 3 bigger than whatever x is. So we're going to assume that x plus 3 is always going to be a positive number. So what we can legally do, without affecting the inequality, is divide each of these pieces by x plus 3. And again, the reason we can do this legally without changing the direction of the inequality is because we can assume x is greater than 0. And again, why can we assume x is greater than 0? Because we're taking the limit as x goes to infinity. So, really big numbers are definitely bigger than 0. So what do we now have? We now have the function 2 minus cosine of x over x plus 3 sandwiched between 1 over x plus 3 and 3 over x plus 3. Alright? So we have the first part of the setup of our squeeze theorem, right? The squeeze theorem says that we have to have the function that we're looking for, which is, what do they call it, g, right? So at this point we're thinking of this as g of x, and it's sandwiched between f of x on the low side and h of x on the high side, right? So we know this function is always between 1 over x plus 3 and 3 over x plus 3. But what else do we know? Right? So we know this. This is kind of like number 1. But number 2 is the fact that what's the limit as x approaches infinity of 1 over x plus 3? Well, what happens? As x gets really big, the denominator gets big, and the numerator is still 1. So this thing is actually approaching 0. Right? The denominator gets big, the numerator is 1, so 1 over a really big number is getting close to 0. And also, the same thing with the function on the right. 3 over x plus 3. The denominator gets really big, the numerator is 3, so this is also going to 0. So now, because I have the initial setup where I have g sandwiched between f and h, and I also know that the limit of f is 0 and the limit of h is 0, now I can conclude by the squeeze theorem the limit as x approaches infinity of the function that I wanted, 2 minus cosine x over x plus 3, is also equal to 0. Right? And generally that's how you're always going to apply theorems in calculus. You're going to show that the hypothesis, right, the if part, if you will, is true, and if the if part holds or is true, then you can conclude the conclusion. So in this case, I was showing that g of x is always between f of x and h of x, and f of x and h of x both had the same limit as x approaches infinity, which equals 0. So therefore I could conclude that my middle my middle function g of x also had the same limit, which was 0. And you can also see this graphically, obviously, just by graphing the three functions, right? So I have 1 over x plus 3, which is in green, 3 over x plus 3, which is in red, and then the function that I'm trying to find the limit of, 2 minus the cosine of x, all over x plus 3 in the purple. And if I look at these graphs, I can see that the purple graph is always between the red and the green one. And what happens as I move further and further to the right? The purple one stays between the green and the red, but the green and the red graphs are getting closer and closer to 0.